Yo, what's really good, brothers and sisters? I am your host, your brother, your professor, Mr. O'Neil Barnaby, founder and director of the Black Math Academy, here with another video showing you guys exactly what intelligent black society is all about. Right, so continuing with my series on tips, tricks, and alternative methods, today I'm going to be talking about circles. I'm going to show you guys some of the basic concepts when it comes to circles, and I'm also going to discuss a neat little trick that'll help with some of your more basic circle problems. So, we won't be able to circumvent this one. Whatever. So, circles, first of all, let's define it. What is a circle? So, a circle is a round figure where the points along the outside rim or the circumference is equidistant from another point called the center. So if we have this circle here, circle O, because the center of a circle always labels it or names it, every point along the circle's circumference is the same distance from the center. So B to O, G to O, F to O, D to O, C to O, E to O, A to O, and every other point in between all have the same length. Okay? So these 6 concepts here, radius, chord, arc, diameter, secant, and sector, are some of the basic parts when it comes to circles. So I'll go through each one of those to let you know exactly what they are. So first we have a radius. A radius is the length of a line that starts from the center of the circle to the edge of a circle. So in this particular case, we have the center being O and the edge being A. So that line from O to A would be a radius. So radius, an example of that one in this figure would be OA. A chord is a line that connects 2 edges of a circle. So we have an example of a chord with the line DE. D touches one edge of a circle, goes through it, and hits another edge of the circle, point E. So that line DE would be a chord for this circle. So chord, our example would be DE. An arc sounds just like its definition. It's basically a piece of the circumference. So you just kind of go starting from the circumference at one point, you travel around it till you end at another point, and that distance would be an arc. So we have plenty of examples on this circle. I'll just choose one where point A to point E, if you were to travel along that particular part of the circle, that would be an arc. So one example of an arc in this figure would be the arc AE. All right. A diameter is actually a special kind of chord. Remember, a chord is a line that connects 2 edges of a circle. A diameter is also the same thing. It connects 2 edges of a circle, but also goes through the center of that circle. So by definition, a diameter is a chord. It's just a special kind of chord. But not every chord is a diameter. So in our figure here, one example of a diameter would be from B to C, because this line BC goes through the one edge here, but also goes through the center, the center being O. So the line BC would be a diameter for this circle. So BC. A secant. A secant is a line that cuts through a circle. So it'll hit 2 edges of it, but it'll actually go through it. So in our example here, we have the line FG. It hits F and G, the 2 edges on the circle, but also happens to go through the circle itself. So that kind of line is what's called a secant. So FG would be our answer for that one. There is a trigonometric definition of secant, but I won't talk about that here. Probably in another video I'll go into geometry, specifically trigonometry. And last but not least, we have a sector. And if you don't notice the definition of that word in like the dictionary, a sector is basically a piece of the area of a circle. So since a circle is a circular figure or round figure, Think of it like a pizza slice or a slice of pie. That shape that a slice of pie makes or a slice of pizza makes is what's called a sector. All right, so we have one sector here where we have BOA. So as you notice, it took 3 points to actually label that value, this idea here of a sector. So it resembles a pizza slice. We have this thing here. And that area between B, O, and A would be a sector. So a sector in this particular example would be B, O, A. And those would be the basic parts of a circle, which you definitely need to know to understand so that you can solve any circle problem. All right. Now, the second thing I want to talk to you guys about is this acronym that I came up with. The acronym is called C.A.R.D. C.A.R.D. are its initials, and each of these initials stands for a particular aspect about a circle. C stands for circumference, A stands for area, R stands for radius, D stands for diameter. And the reason I want you guys to know about it is because if you happen to know any one of these concepts, you can actually use that to be able to determine the other 3 concepts within that acronym. So allow me to demonstrate. So C, let me switch this up. So circumference right? Its circumference is like the perimeter of a particular shape, but because perimeter pertains to shapes with actual sides, we won't use the phrase perimeter. We actually use the phrase circumference instead because a circle doesn't have any sides. So the formula for circumference is 2 pi r, or pi times d. Okay, R stands for radius and D stands for diameter. So A, which is area, its formula is pi r squared. All right, R stands for radius. So radius, its formula is actually D divided by 2. And the diameter, its formula is 2r. Okay, so these are your formulas. Circumference, 2 pi r, or pi times diameter. Pi d, area, pi r squared. Radius, diameter divided by 2. And diameter, 2 times the radius. All right, so if you're paying attention, what you'll notice about all 4 of these equations is that they all have something in common. That something is the value r. Circumference is 2 pi r, area pi r squared, radius is just, well, d divided by 2, but it also equals r. So let me write that too, or r. And diameter 2 pi r, or just d, for diameter. So they all have r. R here, r here, r there, and r there. That makes all 4 of these concepts related to each other, and because they're related, we can then actually solve for each one. So let me actually give you an example. Let's say this particular circle, let's say its circumference is equal to 12 pi. Okay. Actually, let me talk about pi for a moment. Pi, its definition is the ratio of the circumference of a circle to its diameter. Unfortunately, that particular expression can't be shown as a finite decimal or finite value. So that's where we get the value 3.14 from. You take the circumference of the circle, divide it by the diameter of that circle, and the answer is always going to be pi, 3.1415, and it continues on forever. But we can't express that as an actual number, so we use the symbol in replace of that. But anyway, let's say our circumference of this circle is 12 pi. Okay, with that being said, let's see if we can figure out the radius. Okay, so the radius is r, or d divided by 2. In the formula for circumference, pi times diameter is another way of looking at it, and that particular expression looks just like this. We have pi in both of them, and d is in this one, but 12 is in the actual value. So logically speaking, it makes sense that 12 is the diameter based on that relationship. So that means the diameter of our circle is 12, so we can actually write that down. And since d divided by 2 is the radius, so 12 divided by 2 would be the value of our radius. In this case would be 6. And now that we have that, we can then find the area of this circle. Area says pi r squared. R happens to be 6, so we plug that into the formula. 6 squared is 36, and 36 times pi is just that. So 36 pi would be the answer. So you can now see, here are our answers here. So this particular acronym, C.A.R.D. or C.A.R.D, circumference, area, radius, and diameter, they all happen to be related to each other. So if you know just one of these concepts, no matter which one, you'll be able to use that information to figure out the rest of it. So no excuses. Did you see that? So that is another example of what Intelligent Black Society is all about. Don't forget to like, share, comment, and subscribe to all of our social media pages, our Facebook, our Instagram, and our YouTube pages. And always remember that the strong take from the weak, but the smart take from the strong. Math is where it's at.